Hi everyone, today we're going to be talking about paper circuits and how to troubleshoot them. Because as you are working on this project, you are going to notice that things can and will go wrong. You will put in your battery, you'll have soldered down a bunch of lights, you'll be all ready for everything to work beautifully, and it just won't. So we want to talk today about some common problems that can arise with paper circuits, how to figure out that that's what's going on, and how to fix it. So there are 5 common problems I want to make sure that you understand. The first is a pretty simple one. It's that your LEDs might not be properly connected. So if you didn't solder down your LEDs, if they're just taped down, or if you made the gap between your copper tape really wide and your LEDs aren't big enough to bridge that gap, you just might end up with a situation where your LEDs aren't actually connected to the copper tape on either side, and as a result don't light up. So that's one common mistake. The next common mistake is to have the LEDs be backwards. So remember that there's that green stripe on the LEDs, and that little green stripe has to go towards the negative line of the battery. So if you don't set this up in such a way where that green stripe is heading towards the negative line, then it's just not going to light up. Third issue, if you have not been careful with your batteries and you maybe left them in your paper circuit, or you stored them near metal things, they might have drained. And if your battery is drained, it means there's no electrons flowing through your circuit, so nothing lights up at all. The last 2 are sort of the more difficult ones. These are, you can have a break in your copper tape somewhere, or someplace where there's not actually a closed circuit. If your circuit is accidentally left open so that there's not actually a full path for the electrons to travel through, you can have what we call a loose connection or a broken connection. And if that's the case, then there's no electricity flowing through your circuit at all. And then last but not least, the absolute worst way things can go wrong is to have a short circuit. And short circuits are when there is a path for the electrons to take that bypasses the LEDs entirely and allows the electrons to just move directly from one side of the battery to the other. It's the hardest one. It's easy to diagnose, to know that that's the problem, but it can be really difficult to find where things have gone wrong and to fix a short circuit. So I really recommend being careful as you are designing, planning, laying out your copper tape to make sure that you're not creating one of those by accident. So what we're going to do is we're going to go through these one by one, and we're going to talk about how you would notice that this is the problem and how you would fix it. So for poorly connected LEDs, a couple key giveaways. If you can make the LED light up by like pushing on it or maybe wiggling it a little bit, that's a dead giveaway that this is just the LED isn't really connected down properly. Another thing that can potentially cause the problem is if there's an LED that's not lighting up, look at it and make sure that those ends of the LED are actually resting on the copper tape. If that gap is really wide, the LEDs are not going to be able to bridge it. You cannot solder onto paper, right? If you try to solder onto paper, you're just going to char the paper. So if those pieces of copper tape are too far apart, you can't create a connection across that. You need to lay down new copper tape and make that connection, closer, make it a smaller gap so the LEDs can actually bridge that. And to fix this, first suggestion is to solder or solder instead of relying on tape. If you solder the LEDs down, then you're much more likely to have a good firm connection. If the problem is that your copper tape is too far apart, you just need to lay down new copper tape that's closer together. And that's absolutely something that is easier to just fix the first time rather than trying to bridge a wide gap. Like, it's a lot easier oftentimes to just lay down new copper tape. Next issue is backwards LEDs. So if you look at the top of your LEDs, there is a teeny tiny green stripe or perhaps a black like fleck. And that little mark goes towards the negative line from your battery. If you put the LED on backwards, it does not work. This is a really easy thing to diagnose because you can just turn your battery over and flip which side is positive and which side is negative. And if you do that, then basically all the LEDs that were working will stop working, and the LEDs that weren't working will turn on suddenly. And that just means you put those LEDs on backwards. So the easiest way to fix this is pretty simple. You have to unsolder the LED, which means melting one side of the tin, prying it up out of the molten tin, and then melting the other side and lifting the LED out. It's pretty hard to unsolder an LED. So again, this is something where every time you're soldering an LED into place, you really just want to look at it carefully and make sure you have it in the right orientation. Prevention here is so much easier to deal with than having to go back and fix it. Dead batteries are one of those things that can be super frustrating. I've had people who have gone through just like troubleshooting step after troubleshooting step after troubleshooting step, and they're like, nothing is working. And then we realized their battery was dead. So if you've got a neighbor whose battery works, and you know that their battery works because when they stick it in their circuit, it lights up, try borrowing, with their permission, that battery and seeing if it makes a difference in your circuit. If your battery isn't lighting things up, but their battery works, it's just that you need a new battery, and you can ask your teacher for one. So ask for a new battery if you need one, and try not to leave your battery in a position where it can drain. Now we get into the more complicated ones, where we get to use an exciting tool called a multimeter. So the multimeter is a tool that has a whole bunch of different options. There's so many different things that this can do, but we only care about one. The one that we care about is this one right here. It looks like a volume indicator, or like maybe like a Wi-Fi symbol turned on its side. And what that option on a multimeter does is we've got these ends to the multimeter, and if the ends connect, it beeps. So we can use that as a technique for determining if there's a break in the connection. So what you can do is you can set your multimeter to the volume setting, put one end of it at one side of the line, trace along your line, and see if there's any point where there's suddenly a break, where it was making noise and now it's not. And that's a great way to tell right exactly where the problem is. It's very common for the copper tape to sort of snap, especially if it's going around a corner. Like say you've got it moving around, if there's copper tape crossing a crease in a card, at that crease, it's likely that the copper tape will break eventually, just from use. So if your circuit was working before and suddenly it stops working, that is oftentimes a result of a break in the connection. And you can diagnose that with a multimeter. And once you've diagnosed it, you just need to put a little patch of copper tape over the broken point in order to get it working again.
All right, let's talk about how to use my multimeter to diagnose a broken or loose connection in a paper circuit. So I'm going to take my multimeter, I'm going to turn it on, and I'm going to set it to the symbol that looks almost like a volume meter, or it's like a Wi-Fi symbol turned on its side. And what that setting does is it causes your ends of the multimeter to beep if there is a connection between them. So here I have the positive line of my circuit, and that should be a continuous unbroken line. So if I have one end at one side of my positive line, and I move my other end along that line, it should beep everywhere from the very beginning to the very end of that line, right? So there's nothing wrong. That is an unbroken line. On my other side, I could do the same thing. Still have a connection because it still beeps when I touch it down. So we're still connected here. Uh-oh. Here we're connected, here we're not. So right here, I've got a spot where something has gone wrong and my connection is broken. And if you look really closely here, you can see that my copper tape has actually cracked there. That's really common to happen across areas like the edge, like corners or places where the paper is folded. Oftentimes it'll break. So to fix that, I'm going to need to create a patch. So I'm going to take a piece of copper tape. I'm going to fold it over on each end, so I've got a bit of conductive material on each side. And I'm going to put that down over the break just to create a little patch. Oops, make sure that I don't create a short circuit along the way. Lay that down. And what I can do here is I could either, if I have a soldering iron, I could put a little blob of solder here and here to permanently connect it down. Or if all I have at my disposal is tape, I could use some Scotch tape and I could just tape those two edges down. So I could tape that down really firmly to close that connection. I could tape this down really firmly to close that connection. And now, if I use these leads, I should have a connection Yep, now I'm connected well all the way to the end of my negative line. So my negative line is one unbroken connection, my positive line is one unbroken connection, my LED is bridging the gap between them. And now if I put my battery in, it should light up just fine. So that's how you fix a broken connection using a multimeter. And the multimeter can actually help you find the exact spot where it's broken.
Now the next problem that we oftentimes have is called a short circuit. Short circuits are really tough. They're very easy to tell if this is the problem, but it can be really hard to actually find the exact spot on your circuit where things have gone wrong. So what a short circuit is a shortcut for the electrons to move through that doesn't involve going through your LEDs. Typically what causes this is one of two things. Either your positive and your negative line are touching and the electrons can go straight through the copper tape, or when you were soldering down an LED, you used so much solder that you actually created a little bridge made of tin that crossed from your positive line to your negative line. And either of these can result in a situation where there is an easier path for the electrons to move through your circuit that doesn't go through your LEDs. And so the electrons don't go through your LEDs and nothing lights up. Now, using our multimeter, we can easily diagnose that there is a short circuit. The hard part is figuring out exactly where. So your positive line on your circuit and your negative line on the circuit, they should not be touching. There should not be a path from positive to negative. So if I put one of these leads onto the positive line and one of these leads onto the negative line, it's not supposed to be, right? If everything is going correctly, it should not be if I've got one on the positive and one on the negative. If, however, there's a connection between those two lines, it'll be, and that will let you know that there is a short circuit somewhere on your project. At that point, you kind of just have to pore over the entire project, look for spaces where maybe you used too much solder and you created a bridge made out of solder, or where your negative line and positive line are touching, and that can create the short circuit. Another frequent cause of short circuits is if you are doing a project where you have a button, make sure that the button isn't connecting your positive to your negative line. You can also run into difficulty with projects where your paper is folded, because maybe if your paper is unfolded, it might not look like anything is touching that's not supposed to be, but perhaps when you fold it, a bit of the positive line crosses the negative line and it creates a short circuit and things stop working. So look out for, are you folding this in some way that's creating a short circuit? Are you, is your button creating a short circuit? Did you create a short circuit out of solder? Are your positive and negative lines touching?
All right, let's talk about how to use a multimeter All right, let's talk about how to use this tool, which is called a multimeter, to diagnose a short circuit. So this is a multimeter. It's currently set to off. Right here you can see. What I want to do is I want to adjust this to the setting that looks like a volume control or like a sound wave. It almost looks like a Wi-Fi symbol on its side. And I want to make sure it's set to that option. And what that option does is basically I have these two leads that are attached to my multimeter. And if there is a circuit that connects these two leads together, it will beep. And I could do that with anything made of metal. So for example, these scissors are made of metal. If one part's touching and the other part is touching, it'll beep. So the reason why this is useful for a short circuit is that your negative line and your positive line are not supposed to be touching. If your negative and positive line touch, that means you've created a short circuit. So let's say I have a situation like this where for some reason this light is not lighting up and I'm not sure why. One of the things I could do is use my multimeter to try to diagnose a short circuit. And the way I would do that is I would put one end on the negative line and one end on the positive line, and if it beeps, it means there's a connection between those two lines. It's beeping. That's not great. My negative line and my positive line should not be connected to one another. So since that's beeping, what I need to do is I need to go along this line and see if I can find a spot. Over here it looks like they might be touching. And I need to just sort of separate out those two lines. Sometimes, see over here, it looks like maybe we've got a little bit of stuff touching. So I like to sort of separate them. Maybe use your fingernails. Maybe you need to, use the edge here to kind of peel them apart. But if you can make it so that those lines are no longer connected, then hopefully your light should work. So remember, a short circuit happens because your negative line is touching your positive line, and you can use the multimeter to determine if that is the case.
So I have made for you this flow chart, and it basically talks you through how you are going to figure out what's wrong. So if you start at the beginning, it just asks you questions. Is it just a few LEDs or is it all of them? And if you follow through and say, it's only a couple LEDs that aren't working, it'll take you to the options that could potentially be problems. So this is a really good tool that you can use to help figure out which of those 5 common mistakes is plaguing your project. So before you come to your teacher for help, I do want you to make sure that you go through this and you see if there are any issues that could potentially be diagnosed yourself. That ability to troubleshoot, to recognize that there's a problem, to figure out what the problem is, and at least make a good faith effort to fix it yourself is something that is a big part of this project.